Now the next topic of our chapter is wave function and its characteristics. It's an important topic. What is the definition of wave function and also some characteristics of wave function. First of all, what is this wave function? It is actually a function which is used to represent a wave. Any wave can be represented by a function called wave function. Simply, it is a function used to represent a wave. We are considering about waves, right? Suppose we have an electron associated with we have a wave. So a function is used to represent this wave. That function is known as wave function. So simply, it is a function used to represent any wave. And the format of this wave function is psi of rt. Symbol is used to represent wave function is psi of rt, where r is the position and t is the time. So the physical meaning of wave function is that it's actually the physical quantity that makes periodic changes with the wave. It's very important. It's a physical quantity which makes periodic changes with the wave, which means suppose we have a wave is traveling like this. Which quantity makes a periodic changes with this wave? That quantity is actually the wave function. For example, in the case of sound wave, we are considering a sound wave. Actually, pressure is varying, right? Some portion will be compressed, other portion will be rarefaction, again compression, again rarefaction. That will be the propagation of sound wave. Here the pressure is high and the pressure is low, right? So pressure is periodically varying when a sound wave is moving. So that we can conclude pressure indicates the wave function in the case of a sound wave. So that is a physical quantity that makes periodic changes with the wave. In the case of sound wave, it is pressure. In the case of EM wave, that is electromagnetic wave, what are the quantities that makes periodic changes with the wave? These are electric and magnetic fields. Here electric field as well as magnetic field varies with respect to the propagation of wave. So these two quantities represent wave function. That is the inner meaning of a wave function. That is a physical quantity which makes periodic changes with the wave. That is the definition of wave function. So any wave can be represented by a function called wave function. Psi of rt, r is the position and t is the time. Now what are the characteristics of wave function? There are a few characteristics. First one is, again, it is a function of position and time. This is the first property, right? Psi is equal to psi of rt. Wave function is a function of position and time. R is a position. R may include x, y and z. That represents the position of the particle and t the time. That is first characteristics. Second one is, it is continuous and a single valued function. Wave function will be always continuous and it will be a single valued function. The third one, it is a complex function. Not at all a normal function. It is a complex function in nature. And these two characteristics are very important. First one is, it represents the state of the system, because wave function provides the information about the state of the system. Now the particle, where the particle resides, what is the position of the particle, what will be the state of the system. So wave function provides the state of the system, that is the current state of the system. It also provides the probability of the system, probability of the particle. That means it provides the probability of seeing the particle in a future time. So it provides the future probability of seeing the particle. That's also given by this wave function. So wave function provides the information about state of the system, that is current state of the system, also the future probability of the particle. So this probability can be normalized. That is very important. This probability can be normalized. So what is this normalization condition? Actually, normalization condition is two integral. So first integral is this one and the second one is this. That is wave function provides a probability. That probability can be normalized. So what is this normalization condition? It represents two integrals. First integral, psi of rt, integral psi of rt, psi star of rt d2 is equal to 1. And the second one, integral psi of rt, psi star of rt d2 is equal to 0. These two integrals are known as normalization condition. So look at the terms. What is psi of rt? Psi of rt is simply the wave function. And what is this psi star of RT. Psi star of RT is the complex conjugate of psi of RT. Suppose we have a complex function a plus IB, we will write a minus IB as its complex conjugate, right? So that the psi star of RT is the complex conjugate of psi of RT. Psi of RT is a wave function, it is its complex conjugate, and d2 is equal to dx into dy into dz, which is known as volume element. So that is the terms of this integration. Then now integral is equal to 1. Suppose we are finding this integral and this value of this integral is equal to 1, which means there exists a particle. For particle, this value will be 1. If it is equal to 0, that means no particle exists in this area we are considering. So these equations are known as normalization condition. If the value of integral is equal to 1, there exists a particle. If the value of integral is equal to 0, then there will be no particle. That is normalization condition. And we have a relation here. Just remember this relation. Psi star is equal to mod psi square. Psi into psi star will be always equal to modulus of psi square.